Industrial plants like yours use many different types of pumps. One of the most common types of pumps that plants depend on is a centrifugal pump. Centrifugal pumps use centrifugal force to move process liquids. One basic requirement that affects the operation of all centrifugal pumps, large or small, is that they must be primed. In other words, the pump casing and suction line must be completely filled with liquid before the pump is started. If a centrifugal pump isn't primed, it won't operate properly. Now, some centrifugal pumps stay filled with liquid when they're shut down. These pumps are often called self-priming pumps. Sometimes they have components, such as check valves, that maintain the prime after the pump is shut down. In other cases, the system is built so that liquid does not drain out of the pump after it is shut down. So, with some pumps, you may not have to prime the pump, but this isn't always the case. In some cases, it may be necessary to prime the pump manually. A common way to prime a centrifugal pump is to open the pump suction valve and the vent valve. Opening these valves allows liquid to fill the pump and air to escape. In order for this to work, however, either the level of liquid to be pumped must be higher than the casing of the pump, or the suction pressure must be great enough to force the liquid into the pump. If the pump is handling a hazardous liquid, the casing vent should be piped to equipment that will prevent the escape of hazardous liquids. If the liquid level is below the pump casing or the suction pressure is too low, a variety of devices can be used to prime the pump. In some applications, a vacuum system is used to draw air out of the pump. By drawing air out, this system primes the pump. Once the pump casing is full of liquid, the vent valve is shut, and then the pump driver is started. Centrifugal pumps can be started up and shut down in a number of ways. The procedures that are used often depend on the type of centrifugal pump you're working with, the type of driver that's used, why the pump is being shut down or started up, and company operating procedures. We're going to look at some basic steps that can be followed to start up and shut down most centrifugal pumps. But keep in mind that you'll always need to follow the specific procedures used by your company. You should also be aware of the effect that starting or stopping the pump will have on the process. This is the pump we'll be using. It's a single-stage centrifugal pump, and it's part of a system that supplies cooling water to a facility. The pump is driven by an electric motor. Water flow into and out of the pump is controlled by isolation valves. The pump shaft is sealed with a mechanical seal. One of the first steps in the startup procedure is to check the pump suction pressure. In this case, that's done by checking the level in the system expansion tank and making sure that the pressure in the expansion tank is correct. On this pump, the expansion tank ensures that there is sufficient suction head for the pump. Also, the pump and its driver should be checked for obvious signs of damage. On some pumps, auxiliary equipment may have to be checked before startup. For example, the lubrication systems must be checked. Also, sealing liquid to a mechanical seal may need to be lined up to the seal. Once the preliminary checks are done, the next step is to line up the valves in the cooling water system. This step is based on the pump startup procedures, which specify the valves to open or close and the proper order. On this pump, the suction isolation valve is opened. Opening this valve provides a path for liquid to enter the pump. The operator then starts the pump and checks it to make sure that it's operating properly. These checks often include checking the pump's suction pressure and discharge pressure, checking the bearings for excessive vibration or overheating, listening for unusual noises, and checking the pump for signs of leaks. Venting the air from the pump while the suction valve is open will fill the pump with liquid. This step is often referred to as priming the pump. The discharge valve on this pump remains open when the pump is shut down, so it's already in the proper position to run the pump. On other pumps, however, the discharge valve may be shut when the pump is shut down. In these cases, the procedures may say to leave the discharge valve shut, to partially open the valve before the driver is started or to fully open the valve before the driver is started. In our procedure, the discharge valve remains open when the pump is shut down, so there is a flow path for the cooling water into and out of the pump. At this point, the control room should be informed that the pump is ready to be started. The operator then starts the pump and checks it to make sure that it's operating properly. These checks often include checking the pump's suction pressure and discharge pressure, checking the bearings for excessive vibration or overheating, listening for unusual noises, and checking the pump for signs of leaks. On some pumps, additional checks may have to be made to be sure that the pump is operating properly. For example, it might be necessary to check the amount of current that the motor is drawing. Okay, that's a basic centrifugal pump startup. Now let's look at a centrifugal pump shutdown. When the pump is no longer needed, the operator receives permission and shuts off the pump's driver. The running pump's discharge pressure should be checked to see if it's normal. If there's no drop-off in pressure, the pump switch is successful. Once the pump is stopped, its suction isolation valve is closed. In this example, that's all that's required to complete the pump shutdown. On some pumps, the suction and discharge valves are both shut when the pump is shut down. This will completely isolate the pump from the system. In this topic, we looked at how some centrifugal pumps are primed and at some general startup and shutdown procedures for centrifugal pumps. Now let's take a minute and try some practice questions. One basic requirement that affects the operation of all centrifugal pumps, large or small, is that they must be primed. In other words, the pump casing and suction line must be completely filled with liquid before the pump is started. If a centrifugal pump isn't primed, it won't operate properly. As an operator, you may be responsible for the proper operation of many pumps. To ensure that they're operating properly, you need to know what to look for to identify potential problems. We're going to look at 3 components associated with centrifugal pumps and at some of the indications of problems associated with these components. Let's start by looking at packing and mechanical seals. On most pumps, the point where the pump shaft leaves the casing is a place where leakage can occur. To prevent process liquid from being lost or contaminated, either packing or a mechanical seal is often used to seal this area. When packing is used, operators should check to make sure that there is a small amount of leak-off to lubricate and cool the packing. If there's too little leak-off, the packing can dry out and burn. If the packing dries out, the pump should be shut down so that the packing can be replaced. On the other hand, if there's too much leak-off, the efficiency of the pump may be affected. To control the leak-off, the packing must be tightened. This should be done by tightening the nuts on the packing gland one flat at a time. Tightening the gland nuts one flat at a time ensures that the gland does not become cocked. Also, this method ensures that the packing is tightened slowly and helps to prevent over-tightening. The correct amount of leak-off may be different for each pump in a process or for each pump in a plant. You should be aware of the leak-off requirements for the pumps you're responsible for. Now, if the pump has a mechanical seal, you should check to make sure that there is no detectable leak-off. Leak-off from a mechanical seal is an indication that the seal has been damaged and should be replaced. If you find a seal that is leaking, you should report it according to your company's procedures. There are other checks that you may have to make on a pump that has a mechanical seal. For example, if the seal is supplied with an external lubricating liquid, the lubrication system should be checked for proper operation. These checks may include verifying that the lubricating liquid is being supplied to the seal at the proper flow rate and pressure. If the lubricating liquid is not supplied correctly, the seal may fail prematurely. If the lubricating system flow rate or pressure is not correct, there may be a problem. In this situation, you should check the pump that supplies the lubricating system and make sure that the valves in the system are positioned correctly. In addition to checking a pump's packing or mechanical seal, it's also important to check the bearings on the centrifugal pumps and their drivers. One of the easiest ways to check a bearing is to touch the bearing housing. This way, you can check the bearing for both overheating and excessive vibration. If you feel excessive vibration, it may be an indication of a problem with the pump. Problems such as bent shafts, broken impellers, and bad bearings can cause excessive amounts of vibration. The cause of excessive vibration can often be determined using vibration analysis equipment. Devices such as thermometers, temperature recorders, and thermocouples can be used to obtain accurate indications of bearing temperatures that can be compared to previous values to see if there is a problem. For example, if the temperature of a bearing is higher than normal, it may be an indication that the bearing is not being properly lubricated or that it is worn out. How the lubrication of a pump's bearings is checked depends on how the bearings are lubricated. Some pump bearings are lubricated with grease through fittings like this. These bearings should be greased periodically in accordance with the plant's lubrication program. Some bearings are supplied by a grease cup. When you check these bearings, the lubrication program may require you to tighten the grease cup so that additional grease is provided to the bearing. Not all bearings use grease as a lubricant. Many pump bearings are lubricated with oil. On some pumps, an oil reservoir is part of the bearing housing, and there's a sight glass that you can use to determine the oil level. On other pumps, an oiler is used to supply oil to the bearings. When an oiler is used, the level in the oiler's bottle should be checked. If the oil level is too low, the reservoir or the bottle should be refilled. Under the heavier loads, the bearings in these pumps require a forced feed system to ensure proper lubrication. A forced feed system may contain its own pump, reservoir, heater, cooler, and filters. The pump should be checked to make sure it is producing the correct pressure. The oil level in the reservoir should also be checked. This can be done using a level indicator or through a sight glass. If the level is too low, the forced feed system may not adequately lubricate the bearings and they could be damaged. In this case, oil should be added to the reservoir in accordance with company procedures. Also, the cause of the low level should be investigated and reported to supervisory personnel. If the force feed system contains a cooler or heater, it should be checked for proper operation. Otherwise, the pump's bearings could be damaged. If the temperature of the oil is too low, there may be too much cooling water flow, or the system's heaters may not be operating properly. On the other hand, if the temperature is too high, there may be too little cooling water flow, or there may be a problem in the cooler or in the cooling water system. In either situation, the temperature of the oil leaving the cooler must be adjusted so that the pump's bearings can be properly lubricated. The oil's temperature is often controlled by adjusting the amount of cooling flow. Many forced feed systems also contain filters or strainers that are used to remove solid particles from the oil. These particles could enter a bearing and cause damage. During normal operation, there is a drop in pressure as the oil passes through a strainer or filter. This drop in pressure is often referred to as a differential pressure, or delta P. As a filter or a strainer collects particles, the pressure drop across it will increase. If the pressure drop becomes excessive, there may not be enough oil flow through the forced feed system and the pump's bearings will be damaged. To prevent this, the strainer or filter element must be cleaned or replaced. Filters and strainers can also be found upstream or downstream of many centrifugal pumps, where they're used to remove solid particles from the process liquid. As particles build up in a filter or a strainer, it restricts the flow of process liquid, and the difference in pressure across the filter or strainer will increase. If a filter or a strainer is located upstream of the pump, excessive particle buildup could cause the pressure at the suction of the pump to decrease. If the pressure becomes too low, the pump could cavitate and be damaged. If a filter or a strainer is located downstream of the pump, excessive amounts of solid particles will decrease the flow of fluid to downstream equipment. To determine if the debris in a filter or a strainer is affecting flow through the process, the readings on pressure gauges upstream and downstream of the filter or strainer can be compared to each other. If the difference in pressures goes above a predetermined limit, the filter or strainer must be cleaned or replaced. If a centrifugal pump is not completely filled with liquid, that is, if it's not primed, it doesn't have the ability to pump liquid. One way that a centrifugal pump can lose its prime is for air to enter the pump casing, causing the pump to become airbound. There are several ways that air can become trapped inside a pump casing. For example, during startups, the casing and suction piping may have to be vented. If a sufficient amount of air remains trapped, the pump will not operate properly. Another way that air can get into the casing is through a leak. The suction of a centrifugal pump is normally at a low pressure, and this low pressure could draw air into the pump through leaks or the packing. On some pumps, the packing is exposed to the same low pressure that exists at the pump suction. On these pumps, the packing is often supplied with liquid from the discharge of the pump. This liquid cools and helps seal the packing. If the flow of liquid to the packing is not adequate, air could be drawn in through the packing. Air can also get into a pump after maintenance. For example, if piping has been worked on, air in the pipes could make its way to a pump. If the air becomes trapped inside the pump, the prime could be lost. There are several ways to tell if a pump is airbound. One way is to listen to it. A pump that's partially filled with air may produce a rattling noise, similar to the noise a pump makes when it's cavitating. However, the noise caused by air binding may be heard only intermittently. There are other noises that may be associated with air being drawn into a pump. For example, if the pump has leaks on the suction side, you may be able to hear air being drawn into the pump. In some cases, it may be possible to see the flow path for the air being drawn into a pump. With sump pumps, a vortex may form as liquid is pumped from the sump. If the vortex is drawn into the pump suction, it provides a path into the pump. When the pump is partially filled with air, the discharge pressure may vary greatly. Also, on a pump that has an electric motor as a driver, the amount of current drawn by the motor may vary greatly. On the other hand, when a pump is nearly filled with air, the discharge pressure may drop to zero and the pump noise may become a very quiet hum. In this situation, when an electric motor is used as the driver, the amount of current drawn by the motor will drop significantly. A problem that's similar to air binding in a pump is vapor binding. With vapor binding, many of the same symptoms may be noticed. However, the causes of vapor binding are slightly different from the causes of air binding. Vapor binding occurs when a pump loses its prime because vapor has become trapped in the pump. The vapor often forms in other parts of the process and is carried along or entrained in the process liquid until it becomes trapped in the pump. Formation of vapor in a process is affected by the liquid's temperature and pressure. Process changes that increase the liquid's temperature or decrease its pressure may cause vapor bubbles to form and become trapped inside a pump. One condition that causes vapor to become trapped in a pump is suction pressure that's too low. The pressure decrease in the pump's suction can cause vapor bubbles to form. When this happens, the vapor could separate from the liquid and become trapped in the pump. As more vapor collects, the pump becomes vapor-bound and may not be able to pump any liquid. If the liquid temperature is too high, the same basic process happens. The high temperature causes vapor bubbles to form. When this happens, vapor may collect inside the pump, and the pump could become vapor-bound. Venting an air-bound or vapor-bound pump can restore the pump to normal operation. However, this may be only a temporary fix. If there are leaks in the suction piping, if the liquid's temperature is too high, or if the suction pressure is too low, some other corrective action must be taken. Some of the fixes are easier to figure out than others and can be accomplished immediately. For example, if a pump has a packing leak that is drawing in air, then adjusting the packing may stop the problem. On the other hand, if the pump is vapor-bound and it's due to low suction pressure or high liquid temperature, then the way the process is operated may have to be changed. Or the problem may be an indication that a component in the system is not operating properly, and the component might have to be repaired or replaced. In this topic, we looked at operating checks that are commonly made on centrifugal pumps and their auxiliaries. We also looked at how air binding and vapor binding can affect a centrifugal pump, and at some of the methods that might be used to identify and eliminate these problems. Now let's try some practice questions. When packing is used, operators should check to make sure that there is a small amount of leak-off to lubricate and cool the packing. If there's too little leak-off, the packing can dry out and burn. If the packing dries out, the pump should be shut down so that the packing can be replaced. On the other hand, if there's too much leak-off, the efficiency of the pump may be affected. To control the leak-off, the packing must be tightened. This should be done by tightening the nuts on the packing gland one flat at a time. Tightening the gland nuts one flat at a time ensures that the gland does not become cocked. Also, this method ensures that the packing is tightened slowly and helps to prevent over-tightening. There are several ways to tell if a pump is air-bound. One way is to listen to it. A pump that's partially filled with air may produce a rattling noise, similar to the noise a pump makes when it's cavitating. However, the noise caused by air binding may be heard only intermittently. There are other noises that may be associated with air being drawn into a pump. For example, if the pump has leaks on the suction side, you may be able to hear air being drawn into the pump.